morning, everybody. Welcome you all. Welcome to this Publicis Sapient Cloud COE DevOps Summit on Anthos. Thanks you for deciding to join on yet another COVID weekend. I call yet another COVID weekend is because weekends are no more exciting to me, right? Um, I don't look forward for weekends like I used to before because there's not much that we could do at this point. But then if you look at it, we've been kept ourselves locked for about 4 months now. And I guess, probably we're going to just be like that for a few more months. But then during this lockdown and all these 3 months, I've been kept thinking that the way things have been, phasing out for us in the context of COVID. And I start thinking that, once I've gone through all the emotions of any situation, something like denial, kind of an anger, emotional about COVID, and then depressive, moods of COVID. And then I started accepting the reality of COVID itself, right? It's not going to be so bad. We've lived 3 months. And once I started accepting this, I started adapting it to the new normal, right? The new normal is a little different, but then I'm getting used to it slowly. If you look at it, our lives have been, we have been, ordering our groceries online. We've been paying our bills online, right? And the new normal is only telling me that there are more things that I'm going to do online. Say, for example, my kids' educations, they're on, moving online. And the one important thing that moved online is me remotely working from my home, right? Organizations like mine and its BCP teams have been relentlessly working to make my, work from home experience seamless and, and continuous and uninterrupted, right? Say, for example, as simple as me joining securely into, logging into securely into a client environment, right? And, or attending a conference call, all right, or conducting an interview online for future hire. All of them it's happening online, and the BCP teams are working relentlessly to kind of provision all these facilities to me, to securely do it from home as well. Having said that, while we are continuing to do it, I felt like, yeah, it's okay. I'm working from home right now, no big deal. I have a few things, but then as luck would have it say, or luck would phase out, eventually. I started having hardware issues on my computer, right? The computer started giving up on me. It had certain softwares corrupted, or it has some drivers broken, and I don't have my IT team handy, right? And it's not handy around, and so that I can bring it into the IT and say, hey, fix this laptop for me, or exchange this for something else, or give me something else, right? Now, what as the next step that my BCP team did is sort of started provisioning me certain virtual desktops, imaged it, Sapient image, so that I can start remotely connecting into those desktops, right? And do whatever I was doing, that I can do it from any laptop, not necessarily say, a laptop that is provisioned by Sapient, right? Now, that's where I feel like these desktops provisioned on AWS, the cloud came to rescue and sort of, told me that I'm living in a digital world, right? The cloud is making and influencing everybody's life to an extent, whatsoever, right? And I'm living in a digital world, and COVID has pushed me further to live much more, deeper into a digital world. I'm sure you all should have, who is driving your technology transformations today, right? There are people like CXOs, CSO, CIOs, and COVID, right? As much as fun is intended, there in terms of saying the COVID is driving your technology transformation, but it's true. It is true that this is the one that is driving the new age technology, or COVID probably will bring in a lot more nuances into the cloud, right? And hence will push us into a much more deeper digital world is what I'm seeing. Now, my introduction quickly. My name is Suresh Perikala. I've been with Sapient for about 10 years now. Um, I've started my career as a performance engineer, but then my cloud has influenced myself as well, right? My whole career is a testimony of how cloud has kind of made my life evolve, or made my career evolve, right? I started as I said, as a performance engineer, writing some custom C++ loops in terms of testing a developer written code on a, say, a physical data center, right? We did not so I tried to just locate a load generator that is much close to the data center and try to shoot load so that I have minimum latency between my load generator and the data center. And I made sure that I had captured certain performance specific information so that I can tell you, hey, here is your responsiveness of your infrastructure or your application that is deployed on infrastructure. But then while my testing continued, applications have moved from physical data centers into virtual softwares, right? Virtual machines. They started deploying applications into virtual machines. And then I had to basically test applications that are deployed on virtual machines and tell them what is the performance gain or loss that incurred by virtualizing your hardware and running application on top of virtual machines. Now it further went upon and moved ahead and said virtual machines are now deployed as containers or self-sufficient containers with their own resource sets and applications deployed into that. And now I had to test containers and understand the performance implications of containers versus virtual machines and running on a physical server, right? And now eventually we have seen that they all died, and we are seeing something called a new age serverless architectures where you do basically upload a code and not worry about the infrastructure at all, right? But then if you look at my whole career has been changing, and the technology revolution that has been happening over time has basically made my career move as a performance engineer to also learn a ton of cloud itself to kind of make me relevant into this, right? Into the field of where we are right now, right? So my career is a testimony of how I got influenced by cloud itself, right? And organizations, they also want to basically excel and stay relevant in the business, right? Some of the core asks of businesses are, say, so for example, they want to basically put the customer first and say, I want to give my best of the best experience to the customers, right? I want to make sure the response times, the responsiveness of my sites are the best of the ability, right? So to the customers. And again, the another key factor that plays in mind of the businesses when they are, dealing with their IT assets and digital footprint is the time to market. They want to make sure a product that they want to deploy to production is basically put into production as fast as possible. That's where a concept of rapid deployment, developer productivity, faster fixes to any production issues, all of that comes into play, right? And now, upon all this, they want security, portability, reliability on their website. They want to have better governance so that they can monitor stuff and also have ability to reduce administrative overheads so that overall they have a specific amount of productivity in general is achieved, right? Are constantly striving to modernize their infrastructure, right? And try to adapt new technologies and platforms and software solutions to meet the needs of the today. We discussed what are the needs today, right? Uptime, more uptime, faster time to market, increased responsiveness, and better experience to the customers, right? So you need systems that can cope up with these kind of modern software engineering approaches and processes, process automation technologies, and these become critical for organizations to survive over time, right? For you to achieve all this, as we have talking about how cloud has influenced everybody's life in the past, I would say the cloud has played a significant role in kind of making this possible for businesses as well in the current scenario. There seems to be a large inclination to adapting multi-clouds and hybrid clouds. And there must be some good reasons why organizations are trying to adapt these multi-clouds and hybrid cloud versus a physical or an on-prem data center alone versus trying to just, adapt one single cloud as a solution, right? Now, let's look at some of the reasons, right? Why organizations are striving to still incline and these multi and hybrid cloud solutions as well, right? Organizations always wanted to go slow in terms of adapting cloud itself, right? They want to modernize it at their own pace. They don't want to basically, kind of overwhelm with the technology that kind of builds, and then, try to just mess up this entire existing and all in the setup in the hurry to just, adapt cloud. The other good reasons why hybrid clouds became popular is a lot of organizations have invested a lot of money on their own on-prem or physical data centers that they don't want to get rid of. They want to still see a way where they could leverage the existing infrastructure, on-prem hardware, and yet, and that's where they preferred not moving the entire, on-prem loads into cloud, but they wanted to do something like a cloud interconnect, right? They wanted to cloud interconnect and try to utilize specific services of cloud, while some of the most of their infrastructure were still running on the right. And high availability is an example of multi-cloud. When you have a specific infrastructure and application running on it, if you want to maintain high availability, a single cloud itself provides you a lot of failovers into the specific region and zone in which you can failover into different data centers. But then, sometimes it's always, they wanted to back up, with another cloud provider as an high availability, right? Again, don't want to get locked to a single vendor, right? Sometimes a specific service on one cloud is much more efficient and cheaper and productive than another service running on another cloud, right? Tenant separation, you want to basically have multiple clusters separated, multiple cloud environments and stuff like that. You may want to basically run your initial untrusted code on one cluster, right? And another cluster. That's why you want to have maintain multiple clusters, either on-prem or on cloud or multiple data or multiple cloud instances, right? The next three reasons are quite important, right? A lot of people, before going into the cloud, they did not want move their data into the cloud for security reasons. They were very, very paranoid about putting data on cloud for all exploitation reasons or vulnerability reasons, and hence they preferred an isolation of application to data planes, where they kind of had the application load work on cloud, and while their data plane or the data is still retained on the and there could be several reasons. One, your own personal preference, and the paramount of data information or PI information that you hold would be the reason. But that could be also a regulatory reason, as a specific country's data cannot be deployed in another clouds and in another country. The whole GDPR compliances of data processing, acquiring data and processing downstream data, and all of that plays in, right? So there could be compliance reasons or the GDPR compliance reasons for which you want to prefer hybrid and multi-clouds as well, right? There are other, simpler reasons like, security, portability, and reliability. You want to basically be able to be agile in terms of, for some odd reason, if you want to move out from a specific cloud of a specific service, you should have the agility to just move on to the cloud. And Amit mentioned about cost being two sides of the coin. It's very well said. Cloud might seem like a silver bullet, but then, it's always a repetitive or a recurring cost that you need to always keep in mind. So there's always a balance that you need to strike out between cost, and hence, you may want to basically explore various options across cloud, various services that are more cheaper than one over the other in the cloud before you make a choice, right? One reason is a very personal reason to the developers, right? A specific, cloud differentiated service that is available on a specific cloud would say, hey, I want to just use that specific. I'm very familiar and I'm very comfortable with that developer tool on and that cloud provides. Hence I would like to prefer that. So there are multiple personal, organizational, cost, compliance reasons for which we may want to basically look at a solution that is scattered on multi and hybrid cloud environments, right? that's where, it gets a little complex. As I said, a cluster running on a single cloud versus all your applications distributed on multiple clouds, and also in your on-prem data center, kind of makes it you for you on right. And that's where Anthos come in, right? Anthos has a platform, has tried to just provision, provide certain capabilities inherently to kind of manage multi and hybrid kind of clusters and environments for infrastructure. Before I get into Anthos, and I would like to take a few minutes spend a time on some of those technologies, the revolution in technologies that we have seen in the recent past, maybe around in the last 7, 8 years, right? These technologies have actually fundamentally kind of shifted, or there seems to be a paradigm shift in the way we built applications and operate and manage applications in cloud, right? The first and foremost thing is Docker. You would have seen as a container management or a container tool. If you remember, Google has been running containers for about 15 years now. But then the primitive containers are not called containers, but they are called as C groups. That stands for control groups, which are majorly running on Linux kernels, right? And then they have been doing so like that for about years. And then Docker came up and put together a cool set of tools that basically can manage containers for you, right? And build, deploy, and manage for you, in cloud, right? While Docker was evolving, Google kind of felt that the containers are now being, uh, there are a ton of containers that are being deployed, and the containers are growing by the day, and right, and they would want probably a good viable solutions that could manage all these containers at scale or orchestrate at scale. And that's when the open source Kubernetes engine has been kind of been released. When it's a release, the trademark and the code and the open source aspects of Kubernetes, and it might be popular or familiar as K8s, has come out into the market, for people to use it for managing containers, at scale, and deploying containers at scale, or scheduling containers at scale, right? Now, the other thing that kind of came along and became popular is the Istio, the service mesh kind of a mechanism that they wanted to have in place so that they can talk between services, communicate between services, apply security policies between the way the services communicate, right? And manage traffic from between services or throttle services. That's where Istio played a major role in managing your services in production at scale as well, right? While these technologies are all coming up and revolutionizing the way the applications are built and deployed on cloud, right? Google tried to understand the customers as well, and try to understand the customers in terms of how fast and slow they were in terms of adapting these technologies, right? Not every technology that you have out there is viable or is a viable solution for a customer today to kind of adapt and implement it for them, right? So when Google did a survey and tried to understand typical cloud users, they found that quarters of the organizations have some cloud presence, not necessarily completely migrating to the cloud, but then have some cloud presence in terms of have, however big or small it is, or probably could be as simple as you leveraging one single service or a native capability of the cloud, while the rest of the all applications had actually, the workloads remain on the on-prem, right? So that's how, but then all the organizations tend and showed some inclination to adapt to, some of the cloud and the cloud services that, right? But yet, it has also noticed that while 73% of the organizations try to adapt some cloud entity, 10% of the workloads are only running on the cloud itself, right? That means your majority of your applications and workloads remained on-prem, right? While the non-critical applications were moved to the cloud, which probably did not, and kind of, retain all the transactional aspects of the application, or the high volume workloads that the application is responsible for, is still retained in the data center, right? There is a reason for which this is happening, and over a time, even the 10% of the customers try to back out for the reasons that while cloud is being kind of advertised as a solution, or promoted as a solution for you to just move on your workloads, there is a lot of preparation for organizations that they have to do before they move on to cloud. So they try to just convert their virtual machines that are running on-prem, toil them, and kind of decouple their applications, and try to just move at the same time into the cloud, right? And that kind of poses certain risks when you're trying to decouple or lose your applications into multiple microservices, and at the same time convert them into virtual machines and containers and deploy them in the cloud. It kind of posed a risk, right? And now they felt that they had two different entities and tool sets and configurations and all of them to be managed at the same point. And and with this kind of posed a challenge for them, right? And that's where the Anthos tried to bring in, and this is for exact reason why Anthos came in and said, hey, this is a solution that we have for managing your workloads and migrating your workloads from your on-prem to cloud, and not only limiting to GCP or managed by the Kubernetes clusters of GKE, but also the clusters that are running on your competitive and another cloud provider, right? All at the same time, right? So Anthos, if you look at it, is 100% software solution. There is no hardware piece to it, unlike some of the competitors in this space, like AKS, Amazon Kubernetes Services, which has a specific hardware that you need to purchase. There is EKS, which is by Amazon, which is enterprise Kubernetes service that they provide, and also sells hardwares in specific hardware that need to be compatible for you to manage hybrid and multi-cloud. And moreover, those competitors turned out to be more like cloud interconnects, kind of solving the hybrid side of the solution, but not necessarily solving the multi-cloud, or trying to connect with multiple clouds and other cloud providers if their workloads are running beyond their one specific single cloud, right? That said, Anthos is a platform, is a result of decades of work that they have put together to kind of stand up in a comprehensive, more advanced platform, that can manage workloads for multiple cloud and hybrid clouds, kind of an infrastructure, right? We were talking about C groups. That's where in 2006, the first form of the primitive form of container has been launched, and then about in 2014 also we had the Kubernetes, open source Kubernetes, right? That has been released to public, to manage your container settler. And then there is a managed version of Google Kubernetes engine called Google Kubernetes Engine that has come out, making it more user friendly for the users to stand up or build clusters on and Kubernetes. And then the key part of the Anthos, and kind of is the backbone for it, is a GKE, a private instance of Kubernetes that is running on your on-prem, which was announced way back in 2018, right? And along came with a few technologies like Istio. We've discussed briefly, and we're going to discuss that detail in our later slides, right? And then the one important thing is Knative came up, which is a set of tools for developers to be able to operate and develop and deploy applications directly to GCP, right? So if you look at it, it's a culmination of work over last 2 decades, that has made possible or build a platform like Anthos, right? So Anthos, to start with, for starters, gives you a different set of tools for different people, right? For the infrastructure operators, there is this Kubernetes that gives you to kind of deploy containers at scale, monitor scale up, scale down your containers, etc., etc. And for the SRE engineers, for purely, Amit was talking about, I have challenges in monitoring and centrally monitoring, all my service traffic and, connectivity and all of that. So that's where Istio comes in, and so that you have a clear understanding of your service to service communication, service to service security, which service can talk to each other. All of that can be, visualized in one single pane as well, right? As I said, Knative is a set of developer tools that Google has provided for you to build and deploy applications to cloud, especially when it comes to GCP. The left side are all open source. They've been there for a while. You guys are familiar with it. The right side of them are the gold class, or what they call, Google call as a gold class managed or a hosted service equivalent of all those products that Google has, and they specifically run on your local VMware, vSphere. I was told that it only supports 6.5 and future, but there are research going on not only supporting VMware, but there are other virtualization softwares that there are out there, like Citrix, etc., etc. Right? Now, so let's talk a little bit on the Kubernetes itself, right? Kubernetes is sort of genesis for Anthos, right? That's the backbone. That's where it basically tells you, hey, I want to aggregate all your clusters, irrespective of where they are. It could be on-prem. It could be on a different cloud than what you are, or GCP, and it could be on your own on-prem data center as well. Now, the cloud native applications, the Kubernetes works you guys, if you're familiar with Kubernetes, they know there are three major reasons that Kubernetes have become popular and has become a de facto solution for managing containers, right? The first and foremost reason is containers are self-sufficient, application forms, right, that are portable and predictable, and comes with a packaged set of resources that run in isolation. It doesn't need anything else. It's a container. It can be ported anywhere, and it can be deployed everywhere, right? And the second good reason, is they are dynamically scheduled, meaning which you can route your containers to various, you can use a specific machine to kind of deploy additional clusters on the different hardware, and make your cluster, containers kind of operate on top of them, right? They can be scheduled dynamically. They don't have to be in a predefined set of hardware or a predefined machine, stuff like that. They can always be floating, and your clusters can be deployed on fly, and then your containers can be deployed into your clusters as well. And one good reason, is on the application side of things, which is the application now, which used to be monolithic, is now decoupled into small chunks or manageable chunks of functionality, and deployed as microservices into containers, right? And they operate independently. They are upgradable independently. They don't have to do anything with each other, right? So these are the three reasons why containers, decoupled architectures have made Kubernetes life so easy. I made Kubernetes the successful container management, for applications, right? Let's see, in a nutshell, kind of, Kubernetes engines we are not aware of, right? The open source, the left side of my screen is the open source Kubernetes engine that we were talking about earlier, which is still out there for public. They could use it to stand up a cluster and scale up and scale down their clusters as well, right? The right side of is the managed version of the Google Kubernetes engine, wherein your master, while it is still managed as a kubectl, as a command prompt, thing to manage your cluster, it also, Google gives you a cool console or a user-friendly console to manage your cluster, right? This would also make easy for people. Say, for example, if you're familiar with Kubernetes, and if you have worked on Kubernetes, you know how difficult is it to bring a cluster up, and to stand up a cluster up on Kubernetes, given the number of configurations, your settings, and policies that need to be in place before your cluster starts showing up. Because your kubectl interacts with a ton of APIs, and it's more laborious and manual in nature to bring it up. So there's a lot of work involved in it. With GKE, the managed version of Kubernetes, you have an admin console, which is essentially a kind of a web console in which you can simply do some clicks, make some settings, configurations, and stand up your cluster in no time. Right? That's where GKE has become popular as a managed Kubernetes engine. The third one is the most important thing, is the on-prem Gke, right? On-prem Gke is predominantly to manage your workloads on the on-prem data center to start with, right? The way it works is, apart from your kubectl that you have to manage your individual clusters or Kubernetes clusters, the Gke on-prem comes with a gke-ctl command prompt. What this does is, it basically installs a virtual machine on your on-prem data center, wherein the virtual machine has a ton of tools to manage your entire, infrastructure that's already there. It has a strong integration with your vSphere virtualization software, and kind of accumulates all your virtual machines as akin to the pods in your cluster, right? And manage them from one single console, right? It also gives you the ability to add perform all the crude commands, such as create, read, update, and delete your entities of your cluster, right, directly from your console, right? So that's about your on-prem, right? This is an on-prem version of a GKE that has become popular or is a key part of your Anthos as a platform itself. Now, the way it connects, right? When you have your GKE cluster running on-prem, you have your GKE cluster running on. You want to basically have one single dashboard view or a centralized view where you can manage this board, right? The way it does is, once you have set up your on-prem cluster and started it, it kind of does one outbound call to GCP. It's a TCL outbound call to GCP to register the on-prem cluster on your GKE on GCP. Now, once this is done, the central dashboard shows you your clusters, which are on-prem and on GCP, and if there are any clusters that you have beyond a single cloud, they are also shown up in your single GCP GKE dashboard in one central view, from which you can manage, deploy, et cetera, right? Since it is an outbound call, your infrastructure and your static details of your infrastructure and your static IPs of your infrastructure on-prem doesn't have to be exposed. They are still safe, and it is only an outbound call, and that's how the communication between the on-prem and your cloud data center happens, right? So that's your first entity, right? The first entity is your Kubernetes. Kubernetes managing a cluster on cloud and also on an on-prem data center, and connecting them both and managing from a single destination.